Now remember, in the previous section, we looked at how we developed this equation for first principles. Now let's do an example to see how we would then apply this equation for first principles. So now, if I said I've got a function f of x is equal to 2x squared minus 3. So this would be a parabola, and I said I want to know what the gradient of this parabola is at x is equal to, let's say, 2. So let's find my m at x is equal to 2. That's simple. All we do is we apply the first principles now to my equation and then sub in x is equal to 2, and that's what will give us our gradient at x is equal to 2. So first of all, before I can apply that equation, I do a few things. I've got my f of x. What I'm going to find is my f of x plus h. That is simple. All that is, wherever you see x, replace that with an x plus h. So my f of x plus h is going to be 2 into the x is squared, so I'm going to have x plus h squared minus 3. Quickly just simplify that. It's going to give me 2x squared plus, that's going to give me xh, 2xh times 2 is going to be 4xh plus 2h squared minus 3. So that's my f of x plus h. And now I can apply this entire thing into my first principles equation and then solve for my gradient. So then my gradient is very important. You have to keep this limit sign throughout. The limit as h tends to 0 of f of x plus h is this whole long thing here, which is 2x squared plus 4xh plus 2h squared minus 3 minus f of x, which is that. So that's minus 2x squared minus a minus 3, which is plus 3 divided by h. It looks hairy and scary, but don't panic. A lot of things normally cancel out at this point. So I've got a minus 3 and a plus 3 there. I've got a 2x squared, a minus 2x squared there. And then I'm left with 4xh plus 2h squared. And what you can notice there, the common factor of h is there, so I can take the h out. So then that's going to be limit as h tends to 0. Like I said, you keep this throughout until the point where you actually evaluate this limit. So I'm left with this. I'm going to take the h out. Where the h comes out, I'm left with 4x plus 2h all over h. Now my h's can cancel, because the thing that you would have noticed initially is that I couldn't apply this limit in the first step because I was going to divide by 0, and like I said before, divide by 0, wormhole, we all fall in, and yeah, trouble. So this cancels with that. I'm left with this here. Now I can evaluate my limit by applying the h is equal to 0, and when I do that, this term falls away, and then my gradient at any given point is merely 4x. But the question was asking what the gradient is at x is equal to 2. That's simple. Plug in a 2 there, and we find that our actual answer is 4 times 2 is 8. And that's how we apply our first principles equation. It's quite easy. The nice thing about this is that this is called finding the derivative of a particular function. Now, they can ask it in very many ways. They can ask you to find f prime of x like that. They can ask you to find y prime. They can ask you to find dy by dx of a function, and so on. So if you see any of these sort of symbols there, it just means find the derivative of the function. If they say find the derivative, find the gradient, or anything like that, this is exactly what you do by first principles. It's a good thing that you actually memorize this. They do come in formula sheets, but I would recommend you memorize this formula. It helps you apply it much quicker, and then you can do this quite easily.